as x cubed minus 50x to the 1/2 power. The reason it's 1/2 power is because there's really a 1 there inside and there's really a 2 there on the outside. This is a power rule followed by a chain rule.
Okay.
So your derivative, your power rule here, 1/2, bring that down front, keep the inside function, subtract 1 from the exponent. So the faster you can get at that, the better. And then you multiply. So we've taken care of the power rule. Now we have to do the chain rule, which is the inside function. So what's the derivative of x cubed?
3x squared minus 50.
Very good. Okay, so you couldn't leave it like this. If you obviously, again, like faster you get at that, the better. Minus 1/2, you'd want to write out for your final answer on that one.
All right.
D is sort of similar because it's better to rewrite it first, and then you say, aha, now I know how to do this. So D, the rewrite here is 25 parentheses x squared plus x plus 2 to the minus 4 power. So whenever that 4 comes up, you negate it. That's this property 1 over x to the n equals x to the minus n. Okay, and then this is a power rule followed by a chain rule.
Okay.
So this minus 4 comes out in front. Now I like at this point, I think you should be comfortable with multiplying it. If you're not, let me know, but it's minus 4 times 25, that's minus 100. X squared plus x plus 2. We're subtracting 1 from negative 4, so that's minus 5. That takes care of the power rule.
Yes.
Now the chain rule, and it's even okay on the test to write this. I mean, they don't care about that when they're grading it. Is now the derivative of the inside part. So what's the derivative of x squared plus x?
2x plus 1.
Excellent. And you can leave it like this. You don't have to simplify it in general.
Okay. Yeah, I think I have a hard time like looking at it and seeing how to rewrite it, I guess. Because once you rewrote it, I'm like, oh, I can do that. But I'm confused. I can't look at it and say that I should rewrite it this way.
Sure. Yeah. And hopefully did you get the impression that it's going to be the same as this with just different numbers?
Yeah. She said to really focus on our notes, and our notes were a lot easier than these problems.
Okay.
And she said that even the review on Matt,
WebAssign.
the WebAssign was like extremely hard. So do that last.
Okay.
So.
All right. Let's do E, letter E here. The outermost function here is the E.
Okay.
So this is like, I call it like derivative of a function. It's like an E, a sine, a log. You first do the function, which in this case is an E, and then you do the chain rule.
Okay.
And there's a lot going on here, but there's no rewrite in this case. 8 comes along with it because it's a constant. The derivative of E is itself. It's exactly the same thing. So that takes care of that part.
Okay.
The chain rule is the derivative of the inside, which is this minus 2x, and that's what you multiply by. What's the derivative of minus 2x?
Minus 2.
Minus 2.
So then would it be negative 16e? Or
Yes.
would you, okay.
You can do that. I mean, do you know if anyone asked, did you ask, like, do you need to simplify? Because generally they say don't in this classes.
Yeah, I think we don't need to simplify based on how long the problem is, but some probably ones that are easy like this, we would need to simplify.
Yes. Okay, so do you want another example of anything like B, D, or E right now?
I would like another example of all 3 of them just so I can get comfortable with rewriting them.
All right, so here's one for B. It's the cube root of x to the 4th minus 40x.
Okay, so then that would be x to the 4th minus 40x, and then like parentheses around those, to the 1 over 3.
Yes.
Okay, and then you do the chain rule, so it'd be 1 over 3 parentheses x to the fourth minus 40x minus
So it's 1/3 minus 1, which is 1/3 minus 3/3. It
okay.
becomes minus 2/3.
And then times 4x to the third minus 40.
Good.
Okay.
Now, like on an exam, what you could do is you could write 1/3 minus 1, and then you can come back and erase and put the right answer.
Okay.
Try not to get caught up in that, because then your brain might forget to continue on with chain rule, which is the whole point of this problem.
Yeah.
This is minus 2/3. Okay, so another one like D is get some more space here. Y equals 15 over x cubed plus 2x minus 3 all to the power of 2.
Okay. So then oh, okay. So it would be 15 parentheses x squared plus 2x minus 3 parentheses.
X cubed here. I changed up slightly.
Oh, okay.
And then what's the exponent here?
-2.
Very good.
Okay, -30 x cubed plus 2x minus 3 minus to the -3rd. I'm sorry,
Yes.
-3
Yes.
times 3x squared plus 2.
Good.
Okay.
Okay, and then another one like E would be y equals -4e to the minus 5x. Just do that.
Okay. So you said that -4 was a constant, and then e to the -5x is the same. And then
Yes.
you'd multiply the derivative of -5x, which would just be -5, right?
Good. Yep.
So then that becomes 20e to the -5x.
Excellent.
Okay.
All right. So 2, letter 2, and then you got A through G. Do you need all of them covered? Do you have some of them already done?
Let me look really quickly. Oh yeah, I would probably need, I mean, we can just do like A and E, because like a lot of them are the same.
Yes.
I would say let's do ED.
Okay, let's start with E.
E
E is, so one more time. So the E, and then
I would say A, B, E, F, G.
all right, got it. All right, so letter A here. It's similar to the last one. The 9 comes with it. Whenever you have a constant out in front, it just comes with it.
Okay.
D dx of natural log of u, and I'm going to use u means whatever's inside parentheses, is 1 over u times u prime. And that's the chain rule part of it. So it's the derivative of the ln of 2x is 1 over 2x times the derivative of the inside function.
Times 2.
Times 2.
Like 2 over 1.
Yeah.
Okay.
And so this one, you again, probably want to simplify unless it says don't simplify. So 2 and 2 cancel, becomes 9 over x.
Okay.
So you try one here. It's probably better do it in this order, if that's okay. Which is that?
Yeah.
All right. So let's go 8 natural log of 4x.
Okay, so you said the constant comes down with it, and then the ln is 1 over 4x times
Yes.
4 over 1. So then that becomes 8 over x.
Yes.
Okay.
Okay, let's do number 2. Or I'm sorry, letter B. It's the next one I heard. All right. So the derivative of ln, again, it's 1 over whatever is inside. So the inside is 5x cubed plus x squared plus 4. 1 over that. Then you have to multiply, that's the chain rule part, the derivative of the inside function.
Okay.
15x squared plus 2x. And then, you know, if you're really adamant about simplifying, you want to you know, rewrite it this way.
And then that would just be the answer.
That's the answer, yeah.
Okay.
Do you want another one like this?
Yes.
All right, so your B here, your B practice is y equals natural log 6x to the 4th plus 3x cubed minus 2.
Okay. So 1 over 6x to the 4th plus 3x cubed minus 2 times 24x to the 3rd plus 9x squared.
Good.
Okay.
And then you can move, essentially shift that over so it's on the numerator.
Okay.
All right. Just a comment on C. The absolute value is just a distraction. You just do it the same way
Okay.
as the other ones. Sorry, that snip is so bad. In C, I'll just make the natural value of an absolute value. This is just a distraction. Just ignore it. Okay, letter E. Letter E is like letter E in the previous one, in the previous set. You bring the constant down when you take the derivative. So you bring the 4 down.
Okay.
The derivative of E is itself. Hopefully that was really emphasized in class.
Yeah.
Okay, and then you multiply, and you got to be careful. Like I've seen some students do some strange things. It's the same line as the 4 and the E. It's
Okay.
not in the exponent here. I don't know if you write big or small, but just be very careful about that. So it's the derivative of this exponent. What is the derivative of the exponent?
5x to the 4th minus 3.
Good. And this is where you get into like, do I simplify or not? You know, like probably, because you'd multiply the 4 times each of these, and it would be 20x to the 4th minus 12 parentheses ex to the 5th minus 3x.
Okay.
And the reason it's in parentheses in front is because they're both multiplying the e to the x.
Mhm.
Sorry, that's not needed there. So if that's clear, did you like one here to practice?
Yeah.
All right.
I guess like my professor kind of just didn't really explain how to simplify everything very well. Like didn't really explain everything. She just like told us to write down the notes, you know? So
Yeah, I mean, it's not great. You're doing the right thing, getting some help. Hopefully this propels you to get a good grade. And I'm assuming this will be your last math class. Maybe you'll have a stats class later on after this. Or
okay, so the 5 comes down and then okay, wait, hold on. Let me write it out really quickly. X to the 4th minus 2x parentheses 4x cubed minus 2. And then you distribute the 5, so that becomes 20x cubed minus 10e to the x to the 4th minus 2x.
yes.
Yeah. Yeah, like see, when you explain it, I understand it.
Excellent. That's great. I think you said to do F and G. Is that right?
Yeah.
Let's do G first.
Okay.
It's a little bit more in the kind of the direction of the same problems. So
Can I actually try this one on my own?
absolutely.
Okay. So it would be e to the 5 over x parentheses, and then you do the derivative of that, right?
Yes.
And then 5 over x, isn't that really just 5x to the negative 1?
Very good. That's the rewrite.
So then, and then you just do the derivative of that, right? So it just being e 5 over x to the negative 5.
You multiply by the derivative of the inside. So you have to figure out the derivative of 5x to the minus 1, which is power rule, and that's what you multiply by.
Okay. So it would be, okay. I see what I did
So
wrong.
d dx of e to the u is e to the u times u prime, meaning like you've done that first part,
Mhm.
and then you just have to take the derivative of 5 over x, and then you rewrite it so that it's easier to take the derivative using power rule.
Okay. So then that becomes to the negative 5, x is negative 2, right?
Very good.
Okay.
Now, potential rewrite here is like putting the negative 5 out front. Okay, e to the 5 over x, and then x to the minus 2 goes down to the bottom as x squared.
Okay. Okay.
Let's try one more. Let's try one more here. Y equals e to the 3 over x squared.
Okay, so the rewrite for that would be e 3x to the negative 2.
I would, yeah, so you can do that. I was gonna say, like, you'll end up wanting like to keep it. That's fine. Yeah, sorry, I shouldn't have said anything. That actually is probably better. Yes,
So then,
yes.
and then that would be negative 6x to the negative 3. So it'd be e to the 3x to the negative 2 times negative 6x to the negative 3.
Very good.
Yeah, I personally like to see like the negative exponents rather than the in the denominator. It just makes sense to me that way.
You did that one much faster, so I would continue to do that for the exam. You can leave it like this. You can rewrite it. It's up to whatever you think the instructor will give you full points on.
Okay.
All right, let's go to letter F. The hardest thing about this part of the course, and for any calculus student, is like knowing which is the first one to start with. And what I see here when I look at the problem, I'm sorry, the screen thing. And obviously I've been doing, why did that happen? Okay. Sorry about that. Go get this back. What I see is a division right here in the middle, and I see a product.
Yes.
And that's what I hope you will see when you see this on the exam, is this is really a product rule.
Okay.
Now within the derivative of each is a chain rule part. So like u times v, that's your product rule. uv prime plus vu prime. This is a kind of a common way to write it. If it's different in your class, let me know. We can use that.
Yeah, we just use f and g. But
F
yeah.
and G. Okay, so you generally keep the first x squared minus 2x, but you have to multiply by the derivative of e to the 2x plus 3.
And then that's just it, right?
It's itself times, and then the chain rule. The derivative of e is itself. That's here where I'm showing, and then you have to take the derivative of 2x plus 3, which is 2.
Okay. Plus.
I don't like the way this is written, but because you generally put the e's. You generally put the e second, but you keep that, and then you have to take the derivative of this thing over here.
Okay.
What's the derivative of x squared minus 2x?
2x minus 2.
2x minus 2. Now, very commonly, these are just left like this. It'll even say on the exam, do not simplify, or no need to simplify. What did your instructor do? Your instructor did simplify. So we can probably do that here if you'd like.
I just have a quick question.
Sure.
I still don't understand how I got the 2 in the first part.
So this, let me grab.
Oh, wait, I do, because you took the derivative of e, right?
Yes, e,
Okay.
and then you have to follow it up with the derivative of the inside.
Okay,
Function.
yes, I do understand that now. So then to simplify, would you just distribute the 2 to everything?
Yes.
On the left hand? Okay.
Yeah. So it's just to these.
Okay.
So 2x squared minus 4x e to the 2x plus 3 plus e to the 2x plus 3, 2x minus 2.
Okay.
Now, if you're actually concerned about being able to simplify, what you have to be able to see is that each of these has a 2x plus 3, e to the 2x plus 3 that goes with it. So what we could do is multiply like this all out, but what you're going to end up doing is just combining these like terms here. And if that's not clear, I can try something else to explain that.
Yeah, can you try to explain it a different way?
Sure. So consider this like this thing right here to just be like W, and this is W. So if you were to multiply that, would be 2x squared W minus 4x W plus 2x W, that's here, minus 2W. And then the W is in all of them. Do you see that? So the W comes out and it's 2x squared minus 4x plus 2x minus 2. And then you're like, oh yeah, I can combine these.
Okay, I see that. So it would be 2x squared e 2x plus 3, right? Minus 4x e 2x plus 3.
If you wanted to write the e, but so like the final answer is where you put the e to the left or the right of it, e to the 2x plus 3. What is it, 2x plus 3? Yeah. Like you only want to write it once. You don't write it with each one.
Okay. Oh, okay, I see now. Okay.
Okay. Do you want to do another one like this?
Yes, please.
Okay. Let me pull up this thing in. Okay, so let's go x squared minus 4x e to the 3x plus 1.
Okay. So this would be product rule. So you would do 2x minus 4 times e 3x plus 1 plus e 3x plus 1 times 3 times x squared plus minus 4x.
Perfect.
Okay.
Yeah. Now, if you look back in your notes, you'll see that that you did like these are switched, but it's correct the way you had it, just in case there's a like, why is it different here? But
okay.
So you want to distribute this 3 to both. 3x squared minus 12x. And you have this 2x minus 4 e to the 3x plus 1. So maybe a better way to look at this is you can actually factor out
a 2.
The e from both. Factor out e to the 3x plus 1. from both, because it becomes e to the 3x plus 1, 2x minus 4 plus that's this over here, and then 3x squared minus 12x.
Mhm.
But again, like you can do this and you should, but you're going to eventually see that you just combine whatever like terms you have.
So it would be e3x plus 1 times 3x squared minus 10x minus 4.
Yes.
Okay.
Very good. Okay, where to go from here?
Oh, I do actually have the
3 is implicit derivatives, and then 4 is
yes. Okay, so 3, the implicit derivatives, I'm just not sure when you write dy dx.
okay. So we'll start with A,
Yes.
and then I may have to give you some other ones that are less complicated than like B or C until it's clear. But yeah, we'll start with this. So when you're doing implicit derivatives, the x is the same as always. Like whenever you see an x, you just treat it like you always do. So what's the derivative of x cubed?
3x squared.
3x squared. Now here's what you do with when you see a y. You visualize an x. So this is not minus y cubed. This is really minus x cubed. What's the derivative of minus x cubed? Or
X cubed. That would be negative 3x squared.
3x squared, but it's not x, it's y. So you write 3y squared. So you visualize an x and you do the derivative as if it's an x,
Okay.
as if x, but you multiply by dy dx.
Okay.
That's only because it's a y there.
Okay. So then that the y would be
So let's
plus
yeah. So what's the
1
derivative? Plus 1, but then
dy dx.
dy dx. And what's the derivative of a constant?
0.
0. So the next step from here, because you have to is, and I use these words, you're gonna move, factor, and then you divide.
Okay.
Okay, so you move the non dy dx terms to the other side of the equation, or you move the dy dx terms to the other side of the equation. It doesn't matter which do you prefer. So I'm either saying move this 3x squared over, or move minus 3y squared dy dx plus dy dx over. Which do you prefer?
Probably the 3x squared to be moved over.
Okay, so this becomes minus 3y squared dy dx plus, now you don't need to write the 1, but you can, dy dx equals minus 3x squared. So we've completed the move.
And then you factor out dy dx, right?
Factor out dy dx. Minus 3y squared plus 1, because there is a 1 there. That's why I kept it. Then you divide. You divide each side by this. There is a lot of writing for these problems, so just be prepared for that when you get it.
Okay.
Can we do one more, like, kind of this, I call this difficulty level before moving to B?
Yes.
Okay. Because B introduces product rule, and it's just uncomfortable. So let's
I have a quick question.
Sure.
Sorry. On the answer, it says 3y squared minus 1 on the denominator. Is that just a typo? Because I also got plus 1.
Yeah, so what your instructor did is they factored out a negative on the bottom. And then they said, oh, that goes with the 1 on the top.
Okay.
So this is like making it pretty. There's this preference not to have negatives in the problems whenever possible.
Okay.
That's all it is.
But we were still correct, right?
Yes. Yes.
Okay, perfect.
Yes. All right, so let's look at a number. Let's say it's a x squared plus y squared minus 3y equals 2x. I want you to try taking the derivative here, keeping in mind all the stuff we talked about in the previous problem. Again, you treat y like an x, and then you always pair it with a dy dx.
Okay. So it'd be 2x plus 2y times dy dx minus 3 dy dx.
Okay,
Okay,
equals,
2.
yes. If this was 2y, it would be 2 dy dx, right? Like it doesn't matter whether it's on the left or the right.
Okay. So
Okay.
even if y, like for it's a negative 3y, you'd still pair that with a dy dx. Is it like
Yes.
anytime you kind of really see a y?
Yes.
Okay.
Yes. Okay. Do you want to do the move factor divide here? Or do you want to move on to 3b?
I think I understand that part. So we can just move on.
All right. So 3b, it has a product rule in it, and I'm just going to cut to, like, this is what, whenever you see an x times a y, this may be, do you get a reference sheet or note card in your exam?
I don't think so.
Okay. So the derivative here is x dy dx, because the derivative of y is dy dx plus y. And you may want to just like memorize this, but we'll try out in this problem and see if it makes sense. Your instructor jumped to a power rule. See, B is really difficult compared to A or even the one I gave. Let's try it. Let's try it here. We'll see.
Yeah, I think I'm hoping that a lot of the review is harder than the actual exam
Yeah.
because we only have 50 minutes to take it too. So there can't be like tremendous amount of long.
No, you're right. You're right. You really are limited on time.
Yeah. So I am hoping that she's not going to be, I mean, she's a nice lady, so I'm hoping for the best. But I do
Have you checked her Rate My Professor to make sure?
No, I haven't, but
Okay.
she's super nice. I
All
love her.
right.
Sometimes I'll
All right.
schedule office hours with her, but like I'm just like, come on, professor, let's get everyone a good grade.
Okay. All right. The the first one here is a product rule.
Okay.
And what I would suggest is to not try to handle the 6 with it and just put it out here.
Okay.
So product rule, F, G.
Got it.
So I think I saw you do the derivative of the first one. Is that right? How do you like to do it?
So we do derivative. So we do f prime times g plus g prime times f or whatever.
Okay, so 2x, because that's the derivative of x squared, hold y, and then you have x squared. What is the derivative of y?
Dy dx.
Yeah, it's 1 dy dx or dy dx, which is perfect. Great. That was good. That sometimes that's unclear. Minus, and then what's the derivative of 15x?
15.
15 equals y squared. So treat it like an x, apply the power rule, and then append dy dx to the end.
Okay, so 2y dy dx.
Dy dx. Now, doing it the way I showed you here, you do have to distribute this in.
Okay.
And so that, like I said before, it's move, factor, divide. There's actually like a simplify step here or a distribute step before you can move things around. But this is 12xy plus 6x squared dy dx minus 15 equals 2y dy dx.
Okay.
And to be clear, from this step forward, there's no calculus. This is all just prerequisite stuff, moving around literal equations, things like that.
Okay. So
you have to either move this 2y dy dx over here to the left, and then move the 12xy and the 15 to the right, or move the 6x squared dy dx to the right.
Okay, so let's do this 6y or 6x. So it'd be 12xy minus 15 equals 2y dy dx minus 6x squared dy dx.
Okay. Now you're up to the factor step. You factor out dy dx.
2y, I'm sorry, oops, so dy dx times 2y minus 6x squared, and then divide that. So then your answer would be 12xy minus 15 over 2y minus 2x squared, right?
Yes. So if you look on the answer sheet, it's got 15 minus 12xy, 6x squared minus 2y. They've just changed the order because they moved dy dx left instead of right.
Okay.
These are exactly the same.
Okay.
I don't recommend doing C unless you really want to.
Yeah, we don't have to do C then.
Okay. 4 is 4 is good for us to look at.
Yes.
Okay. All right, so here's the graph, and this is the graph of F. So just you have to know whether it's F or F prime. You may not be doing that in your class, but it does make a difference whether you're looking at F or F prime.
Okay.
And it does tell you, it says like it ends right there and right there.
Okay.
Okay, so a relative minima is it's kind of like hiking where you think you've from like relative to some other position, you're below it.
Mm-hmm.
This is lower than over here or over here, but it's not the lowest point ever.
Okay.
It's like you climb up and then you go down a little bit and then you come up again.
It's just one of.
I'm sorry.
It's just one of the.
Yes. Yes. I mean, it's below. It's lower than somewhere else, but it's not the lowest ever. The absolute is the lowest ever. And that's where we're going with part B. I'm sorry. Let me do part C next because it goes nicely with this. So part C says absolute minimum. So that's the lowest. That's the lowest overall.
Okay, so that would be 3 and -3.
Yes. Now there are examples where it actually does not have one in this kind of graph. Do you know? Do you know if your instructor covered those kind of weird exceptions? Like, is it going to be this straightforward?
I think so. Yeah.
Okay.
Like those are like endpoints.
Okay. So part B is the like. Let me go up here because we don't lose the graph. Is the absolute max.
Okay.
So the highest points.
Okay.
And notice it's not asking what is the highest point. It's asking where it occurs.
Oh, so that would be like a set of points.
Well, no, it's just the X value. It's just the X value.
Oh.
It's not saying what is the max. It's saying where is the max.
Oh, okay. Oh, I know what you mean now. Okay. So this is just all like graph work. That this isn't really.
Yes.
Okay.
You can do this through calculus, but it's not. It doesn't seem like it's being emphasized in your class.
Okay. Okay, so I guess like what I'm confused on is like the F prime.
Okay. Let me give me just a moment here to get caught up to you. Okay, so the next question is saying F prime of f prime is 0 at x equals. So when f prime of x equals 0, this corresponds to a horizontal tangent.
Okay.
So you're looking for places where it's a horizontal tangent. Another way to it is usually where there's a min or a max.
Okay.
So this is at these three places.
Yes.
I know I've got a lot of writing on this in this graph, but is it clear that like those are horizontal tangents?
Yes.
Okay. So the answer is at x equals -1, 0, and 1, because those are where it is.
Okay. So the f prime is just the horizontal tangents.
Yes.
Okay.
All right. So let me copy this graph down to do letter E and D, because we're going to want to draw on it. So you can see that. All right. So the next question says f prime is positive on the intervals. So f prime is positive if the graph is going up and to the right.
Okay.
It does not matter whether it's below the x-axis or above it. If it's going up and to the right, which it's doing, and let me switch colors here so I can get that in blue. So here it's doing that, and then here it's doing that.
Okay.
Do you see how, do you follow that the graph, like it's referring to the tangents? The tangents are going up and to the right.
Yes.
Okay, so we would say from -3 to -1, comma 0, comma 1. Again, all of these are x values. They're all x values.
So I see where did you get the -3 from?
This right here. It's this x value to this
Oh,
x value.
okay.
It's always the x values in these questions that it's asking about.
Okay. I see that now.
All right,
I
so
thought about the one on the bottom.
I'm going to copy the graph again, and I'll switch to a different color, but this time we're looking for where it's negative. Okay, where it's decreasing, and it's decreasing when it's going down and to the right. I'll write that, but we kind of, negative means it's going down and to the right.
Okay.
So there, and then there, all these, and again, does not matter whether it's positive or negative, whether it's going down and to the right.
Okay. So it would be -1, comma 0, 1, comma 3.
Yes.
Yeah. I'm starting to understand everything. I just don't, I guess the way she explained it wasn't very, or like the lack of explanation wasn't there.
Yeah. So like, let me give you another graph here real quick, so that you can see if you understand. I think you do. And we'll call this, I don't know, I should have used different numbers, but yeah, let me do that. All right, A, B, C, and D. Okay, so from A to B, is it increasing or decreasing?
It's decreasing.
It's decreasing. And how about from B to C?
Increasing.
And from C to D?
Decreasing.
Decreasing. This point up here is an absolute max because it's higher than everything else. This down here is an absolute min because it's lower than everything else. This right here, though, is a relative min because it's lower than the places around it. And this is a relative max because it's higher than the places around it.
Okay.
There's a horizontal tangent. I'll show those in red here and here.
Are they not at the absolute maxes because those are endpoints?
They could be, but they're not the way they're drawn. So
Okay.
what you're asking about, let me create one more graph here so you can see that, because it could be. So if I made something like, oops, so there are horizontal tangents here at the end points, because it kind of comes up like that. If you can hear the dog, it's actually just fine. It just, I don't know if you can hear it or not. There's a dog whining in the background.
Okay, yeah, I see that.
Okay. We're really close to the time here. Is there anything quick? We could kind of look at 5.
Yeah, that'd work. Yeah, that'd be good.
Okay, so like what you normally do is you start with horizontal tangents.
Okay.
So like I see a horizontal tangent there, there, and there, and they want the X values that go along with them. And that's part A. That's -2, 0, 2.
Got it. So then the relative max would be -2, and the relative min would be at +2.
Yes, exactly. Okay. That's it. You got it.
Yeah. Okay, this helped a lot. It made everything a lot more clear, and I'm not as nervous.
Great. Yeah, I mean, hopefully you have time to review what we've done and continue working on this for your exam.
Yeah, definitely. I'm going to the library to do some more practice.
Excellent. Thanks so much for scheduling. I look forward to helping in the future, and I'll send out the notes and the screen recording here shortly.
Perfect. Thank you so much. You have a great rest of your day.
You too. Bye now.
Bye.